Hi, so our today topic is black hole. Explain. Enjoy yourself.
So, the black hole. First, let's talk about how it's made. Like, how star. It's made from a star, bigger stars, bigger than our sun. Our sun's smaller. So those big stars have like a lot of energy. So how stars work is that they have a lot of gravity that's making all the material stay in, not floating away like gravity keeps us on Earth. Now, that gravity has a balance so it doesn't collapse on itself with energy that's coming away. Like the material hydrogen forms into helium, and then at the the time when it forms is at the end of the star's life. Mostly, at the end of the star's life, it's running out of the fuel that it needs. So it has the fuel is it the so the helium that it has, helium turns into elements that become more dense, denser and denser. But all those can make energy and radiation, so it can keep a balance between the gravity and the energy, which is pulling out, and the gravity is pulling in. But when uh, the last element is iron, and iron doesn't make any radiation or energy when made. So it's the balance. There's no energy, so it just the star collapses on itself. But how it's made is that pretend a space has a density. So cotton has very less density. That's why it's so light. But in that same space, you put rock or metal. It's gonna be a lot heavier because it's a lot more dense. There's barely any holes in them in anywhere. But uh, uh, there's density and there's a limit to the density. When it's already full, no holes, no nothing. And after that, it just turns into a black hole. It's like a rip in the space because the density is too much, it can't hold enough. And then a black hole is made. Why it's black is because that much density is like a lot of density. If you put it all together, it like black is the last color. But it also means the density is very, very high. So on that, so so that doesn't mean that if you have a black T-shirt, that it has a lot of density. Only like the real things that are turned black, that are actually made black. So um, that's one way a black hole can be made. Now another way will also have the same thing. It's about stars, but it's like it's two stars. If they're rotating around here, it's a pair, which happens a lot in solar systems. If they go around each other, later they're going to each other and squash into each other. But in that collision, um, they, they will the space it will also the black hole will actually turn bigger because there's two masses, not one. So it will turn into itself, and all the it's not this other concept. Instead, all the energy will turn into will wrap itself into that one place. But since, like I said before, since there's too much energy and the gravity pulls them together, it's gonna collide and turn into another black hole. Another fun fact is, if you want to learn about before in the early universe, when stars were just being made, there's a lot of material. So when a star was made, also known as a protostar, I think, the star, uh, today's stars, they when they're made, they their energy, uh, the radiation pulls all the other material that's left over away, which we have on the outer of our solar system, a cloud, a gigantic one. It's not like any cloud, it's a lot bigger than our universe. I mean, not our universe, I mean our solar system because it covers it. Now, that cloud, when a star is being made, is actually denser and it's closer to the star when. But before there's less space in the universe and expanding slower. I how much I've read. So if you expand, there's less space, and the star, it was actually growing. It wasn't like as at its limit. It was growing and it was getting more of that energy. So as it got more of the energy, it turned extremely big. Like our sun would be this small, and the other star would be extremely big. Now that extremely big star would have a core, but all that energy is too much, and the energy made is not enough for the gravity. Since there's so much mass, the entire star won't turn into a black hole. It won't collapse on itself. Only the core will, which is the inside, which makes the most heat, will turn into black hole, and the star won't die out because it has that much mass to stay alive. But that black hole will keep eating and eating it for millions of years until it explodes in a supernova, which happens at the end of a star's life. And after the supernova, the star will be gone, and though there's black holes that are like mega big. I forgot the word for it. So those black holes, that are there's a theory that it came from those type of stars. There's one star found out like that. So these black holes, I'll explain. So their gravity is infinite. Even light cannot escape it, even though it's the fastest thing in the universe. So since its density is extreme, it's infinite because it's crossed the line, the space. So its gravity will also be infinite, but also, so it will of course consume and become bigger, like everything else, but slowly. Like if a human comes in, it will actually stretch because gravity will stretch it apart. If it comes from feet, it will stretch like spaghetti. So, as I was saying, the spaghettification happens very long. So, there's the outer layer, which is actually not part of the black hole. It's actually the gravity part, and if you reach it, there's no escape. And then, the closer you go in, the less light you see. Pretend if you survive spaghettification, which will actually rip you apart. Now, the inner part is the singularity, the real part of the black hole, which consumes everything, and is actually the part that that was the infinitely dense thing. It's infinitely dense. Its energy is infinitely dense. So it gets it in, and the black hole becomes bigger. Its gravity stays the same. Another thing is, a smaller black hole will pull you in faster than a bigger one. Now, this is the main things about a black hole. Many things about the black hole are very a lot unknown, and that singularity is also what could make a big bang at the end. Now, this is all I have about the black hole.